All right, so this is part 2 of that third packet of notes that I gave you, starting off with solving systems of equations. So we have before, up to this point, solved equations, but here we have a system of equations. In other words, we have more than one equation. At this point, we're only going to do 2. And the solution that we're going to say is going to work has to work for both equations. It cannot work for one and not the other. So it has to work for the system of equations that's been presented to you. So in other words, if I had the ordered pair of 5 and 1, in other words, x being 5, y being 1, the 5 and 1 would work for the first equation and not the second. In other words, 5 plus 1, 5 for x, 1 for y. 5 plus 1 will be equal to 6, but 5 minus 1 is not equal to 2. So the solution for that would be 4, 2. 4 plus 2 is 6, 4 minus 2 is 2. That would be the solution for the whole system, not just one equation. All right, so we have 3 methods that will help us to solve the equations, not just going to go ahead and try to figure it out, but we have actual methods. We have the graphing method, the substitution method, and the addition method. And in each case, no matter what method you use, there are 3 possible outcomes. You have one solution in which you actually have an ordered pair, which is your answer, no solution, or infinitely many solutions. All right, so looking at the first technique, graphing, so you can graph each line on the same plane, then the solution will be where they intersect. So you have 3 scenarios that match the 3 outcomes. So when they intersect, that would be your solution. That's one solution. And you actually give the answer. Whatever that answer is your answer. Is not one solution. The answer is whatever that ordered pair is. The second scenario is no solution. So in other words, if you have parallel lines, that's a scenario in which you have 2 lines that will never intersect. Remember, where they intersect, you get one solution. Where they don't intersect, you get no solution. And then infinitely many solutions, that's when you graph 2 lines and end up being the same line. That's infinitely many solutions. All right, so the first one is that first system that that I initially gave you. We know the answer is 4, 2, so if we do this properly, they should intersect at the ordered pair of 4, 2. So what I like to do is take my equations and solve them for y. I took this one, subtract x from both sides. Y is equal to x minus 6 minus x. Then don't forget, whenever you going to graph your lines, one way to do it, if you create an XY chart, is choose your x value. So I chose -1, 0, and 1. Plug them in. I end up getting 7, 6, and 5 as my y corresponding values. For x minus y equal to 2, solve that one for y as well. I subtract the x from both sides. Then took the negative to the other side, or multiply both sides by -1. And that leaves me with y equal to x minus 2. I chose -1, 0, and 1 again. Plug them in, I get -3, -2, and -1 for the corresponding y values. Now when I graph both lines independently, -1, 7, 0, 6, 1, 5 is the top line. Then -1, -3, 0, -2, and 1, -1 is this bottom line. They intersect at 4, 2. So remember, whenever you try to solve by graphing, where they intersect will be your solution. Here I have 2x plus 3y equal to 12, 4x plus 6y equal to 30. Once again, I solve my equation for y. Subtract 2x from both sides, then divide by 3. When I simplify, taking the 3 into each term, that's -2/3 x plus 4, because the 3 has to go into both terms. So if I decide to use my intercept method, not intercept method, my slope method. Last time I decided to graph using the XY chart. This time I'm graphing using my slope method. -2/3 is my slope, so I'll go down 2, right 3. My y-intercept is 4, so the ordered pair would be 0, 4. Here, I'll go ahead and solve this for y as well. Once I do that, subtract 4x from both sides, then divide by 6. 6 goes into both. That reduces down to -2/3. 30 over 6 is 5. So don't forget, you can look at this and see what should happen once you solve your equation for y, which is why I like to solve my equations for y. It gives you information as to what's going on or what's going to happen. If my slopes are the same, or if they have the same incline, that means the lines are going to be parallel. And we already know if the line's going to be parallel, that means they will never intersect. which means my answer should actually be no solution. So negative 2/3 down 2, right 3, and the y-intercept is 0, 5. So going back to this first line, graph 0, 4, that's right here. Then I go down 2, right 3, that's this point. For the second line, graph 0, 5, which is right here, go down 2, right 3, that's this point. And we have our two lines that are parallel, which means no solution. All right, so for this next one, 2x minus 3y equals 6, 6x minus 9y equals 18. Once again, solve my equations for y, subtract 2x from both sides. Then divide by negative 3. That negative 3 goes into each. That'll give me 2/3 x minus 2. Go ahead and solve this equation for y. Subtract 6x from both sides. Divide by negative 9. And that'll be 2/3 x minus 2. Once again, the same equation. I said once again, didn't mean once again, but notice here we have the same equation. 2/3 x minus 2. So what we do is just graph the one line, 2/3 being your slope, negative 2 being your y-intercept. So that's 0, negative 2. Graph that first. Then I have 2/3, so I go up 2, right 3. And that will be my equation, a graphical representation of both lines. And my answer is infinitely many solutions whenever I'm graphing the same line. All right, the second method is the substitution method. You're going to solve one of the equations for one of the variables, doesn't matter which. Then you're going to take the equation from step 1, substitute it into the equation not used. Then solve for the remaining variable. You're going to take the solution for step 3, back substitute it into equation 1, the equation from step 1. Then we'll solve, and you always check by plugging in both values into your original equations. So we have 5x minus 4y equal to 9, x minus 2y equal to negative 3. So this value right here, this x right here is the easiest one to solve for. Notice neither one of them, I mean, that's the only one that doesn't have a number sitting in front. If there was a number in front of that x, then it wouldn't matter which one you solve for. It will give you the same amount of work in order to solve. But since we have this x sitting by itself, what I would do is just add 2y to both sides. And that would be x equal to 2y minus 3. So that's the end of the first step, taking one of your equations and solving for one of the variables. Notice I use this bottom equation right here. So step 2, I start off with the other equation, 5x minus 4y equal to 9. X is equal to 2y minus 3. So I take 2y minus 3 and plug it in for x. Everything else still should be a part of the equation. I have 5 times x, so there's 5 times 2y minus 3 minus 4y equal to 9. Everything else is still there. That's the end of step 2. Step 3 is we're going to solve. So I distribute 5. So that's 10y minus 15 minus 4y equal to 9. Combine your like terms, 10y minus 4y equals to 6y. Now here I can subtract 15 from both sides. Or excuse me, add 15 to both sides. That's 6y equal to 24. Now divide by 6y is equal to 4. So don't forget you need your x component as well. You have y equal to 4, but you need to know what x is. So now I can go back to this equation from step 1. X is equal to 2y minus 3. Take the y, which is 4, and plug it in for y. 2 times 4 is 8. 8 minus 3 is 5. So my answer is going to be 5, 4 as my order pair. All right, the second method, third method, and final method, and we'll do a few more. I believe I have a few more in this packet to do examples of. It says, if necessary, rewrite each equation as ax plus by equal to c. The first step in the addition method is to rewrite each equation as ax plus by equal to c if necessary. Second, we're going to multiply one of both equations by a non-zero integer that will create opposite coefficients for one of the variables. In other words, I want something like this, 2x and negative 2x, or negative 5y and 5y, because what I want to do is to be able to add these equations together. And when I add these together, these are going to cancel. 2x and negative 2x will cancel. 5y and negative 5y will cancel. So like I said, we'll add the equations together, solve for the remaining variable, then take the solution for step 4, plug it back into the original equation to solve for the other value, and check if you like. Okay, so here we have 3x plus 2y equal to 48, 9x minus 8y equal to 24. Step 1 we do not have to do because we already have it in the form of x, y equal to the constant. Ax plus by equal to our C term, the one without a variable at all. So it's already set up that way. So now step 2, I want to have opposite numbers sitting in front of either x or y. You have to make a decision. Doesn't matter which one you decide. As long as you keep correct with your mathematics, you'll still get the same answer. So either I can turn both of these into 9s. Well, one is a 9. I can turn 3 into 9. Or I can turn this 2 into an 8. All right? I can multiply 3 by 3, or I can multiply 2 by 4. So what I would do is go ahead and multiply the 2 by 4, because not only would I need a 9 here, I need a negative 9. So I would have to introduce a negative. And so, the less that you have to do is the less chance you give yourself for error. So I will multiply this whole equation. You cannot just multiply one term. I multiply the whole equation by 4 so that I can have an 8x sitting in front, 8y, just like I have a negative 8y here. All right. So multiply the equation by 4. I have 12x plus 8y equal to 192. Now I'm going to add that to, that's my new equation 1, my new top equation, 12x plus 8y equal to 192. Now add that to the 9x minus 8y equal to negative 24. When you do that, you see that your 8y's will cancel now. Remember, that's the purpose of step 2, is to figure out what can you multiply to your coefficients in order to create this scenario of canceling out. You have to have a positive and negative value in front of either your x or y. It doesn't matter which one you choose, you'll still get the same answer. So that leaves me with 21x equal to 168. Now I can solve. If I divide by 21, x is equal to 8. So now I can take this x equal to 8 and plug it into either one of these original equations. So I just decided to use the top one. 3 times 8 plus 2y equals 48. 3 times 8 is 24. Subtract 24, that would be 2y equals 24. Divide by 2, y is equal to 12. So my solution would be 812. All right. So if I have 4x plus 6y equal to 12, 6x plus 9y equal to 12. And since it's already set up in the form of ax plus by equal to c, I can use the addition method. Now, notice the 4. I can't turn 4 into 6 with a solid integer. I cannot turn 6 into 4 with an integer. So I need to figure out what's the smallest number, or just a number that I can turn them both into. The smallest number that both of them can go into evenly is 12. So I can turn the 4 or the 6, the 4 and the 6 into 12s. And the same thing happens with the 6y and the 9y. I would have to turn those into 18. That's the smallest numbers I could use. Now, let's say looking at the 4 and 6, I decide to turn them into 24, because 4 times 6 gives me 24. That's fine. That'll still give you the same answer. It's just that you'll be dealing with larger numbers until you get to the very end. Either way, you still get the same answer. But what I'm going to do is decide to go ahead and turn 4 and 6 into 12s. Once again, you could have did 6 and 9 and turned them to 18. Is your preference. Either way, you'll get the same answer if you do everything correct. So if I'm going to do that, I'm going to multiply this top equation by 3. That's what happens here, 12x plus 18y equals 36. And then since everything's positive down here, I'm going to have to multiply the bottom number by -2. Because remember, I need a positive and negative representation of the number that I decided to change them into. So I multiply the bottom equation by -2. That's -12x minus 18y equal to -24. So something in particular, or something special happens here. Notice that when I add these new equations together, 12x's cancel and the 18y's cancel, giving me 0 on the left, and then 36 minus 24 on the right, which is 12. And so going back to when we were solving regular linear equations, remember when your variables cancel, and notice we have 0 equals 12, which is a false statement. When your variables cancel and you have a false statement, your answer is no solution. Remember, no matter what method you use, you have 3 possible outcomes, which is 1 solution, no solution, and infinitely many solutions. So this is what no solution looks like. Variables cancel and you get a false statement. Next one, since I have y equal to 3x minus 2, I decided to go ahead and use the substitution method because I have one of my variables already solved for. So I would take 3x minus 2 and plug it into the other equation where y is. So 15x minus 5y equal to 10. Substitute 3x minus 2 for the y. So it's 15x minus 5 times 3x minus 2 equal to 10. Distribute -5, not just 5, but -5. So 15x minus 15x plus 10. The 15x and negative 15x will cancel, leaving you with 10 equal to 20, 10 equal to 10, which is a true statement. So here, when your variables cancel and you end up with a true statement, this would be infinitely many solutions. So going back, when your variables cancel and you have a false statement, that's no solution. When your variables cancel and you have a true statement, that's infinitely many solutions. All right, one more section, graphing linear inequalities. Remember, we had linear equations before this. Now we're looking at linear inequalities. The difference between your equations and inequality initially is the equation sign versus your inequality sign. So when we go into graphing and we have our inequality symbols, it's going to be a dotted line. If you not inequality symbol, excuse me, we have less than or greater than, it'd be a dotted line. But if we have less than or equal to and greater than or equal to, it'd be a solid line like we normally use. Then we're also going to have to shade, and we're always looking to shade the true side. So let's look at what that means. So let's say if I have y is greater than 2x plus 1. First, I'm going to generate points as if this was an equal sign. So I can use my slope method, I can use my intercepts, or I can use my XY chart. It doesn't matter. You get your points. I decided to use my slope method since y is already solved for. My slope is 2 over 1, which means I will go up 2, right 1. My y-intercept is 1, so that's the order pair 0, 1. So graph that first, 0, 1, then go up to right 1, which would be this point right here. Now, because I have a greater than symbol, that means I have a dotted line. Remember, if it's greater than or less than, it's dotted line. Greater than equal to, less than equal to, would be a solid line. So greater than symbol will give me a dotted line. So now I want to shade the true side. So what I'm going to use is a test value. So you want to choose a point that's definitively on one side of your line. And it doesn't matter what point you choose. One point represents how all the points react on one side, and then it represents how the other ones act on the other side. So I'm going to choose a few points to show you what that means. But when you're doing it on your own, all you really have to do is choose one point. And if it's true, then that means the other side is false. Or when you plug it in, you get false. That means the whole other side is true. So the first test point I'm choosing is 0, negative 1, which is right here. By plugging 0 and negative 1 into the inequality, 0 is x, negative 1 is y. Plug that in. That's 2 times 0 plus 1. Negative 1 is going to be y. That on this right side will simplify to 1. So that'll be negative 1 is greater than positive 1, which is false. So that means everything on the side of 0, negative 1 will be false, and everything on the other side is true. And then, so what I decided to do was choose 2 more points to show you that that is the case. The next one is 0, 5, which is right here. If that, what I'm saying is true, that when I plug in 0, 5, that means that will give me a true result. Plugging in 0, 5, 5 for y, 0 for x. 2 times 0 plus 1 is just 1. So 5 is greater than 1, which is true. So that's what happens on this other side. Now, 4, 0 is on the same side as 0, negative 1. If what I'm saying is true about 0, negative 1, and everything over here should be false. So 4, 0, plug that in. 2 times 4 plus 1 is 9. 0 is over here for y. 0 is greater than 9, which is false. So notice every point that I choose from on this side of the line will be false, and everything on this side will be true. And remember, what you want to shade is the true side. And so that's what we're doing over here. So one more. 3x minus 5y is less than or equal to 15. Once again, set up with equal sign, set it up with the equal sign, generate your points. I decided to use my intercept method. So let y be equal to 0. That leaves me with 3x equal to 15, divide by 3, x equal to 5, so my order pair is 5, 0. By my y-intercept, by letting x be equal to 0, plug it in, negative 5y equal to 15, divide by negative 5, that'll be a negative 3. So 0, negative 3, graph those 2 points. Now, this is less than or equal to, that means I have a solid line. Now, my test point is 0, 0. I decided to use 0, 0. 0, 0 is always good to use if it's definitively on one side of your line. That's the easiest thing to use. So plugging in 0, 0, so 0 for x, 0 for y, that cancels out on the left side completely. Being 0 is less than or equal to 15, which is true. So this side is my true side, the side that 0, 0 is on, and then the other side is false. So I shaded this side. Let me know if you have any questions with anything I've said.